Good morning. David's got some curiosity about Zoe contracts. I had this idea. I administer this, sort of this process that I'll describe a little bit with sort of pencils and baling wire and toothpicks and Google spreadsheets and stuff. And I'm interested to connect it up to the Zoe contracts. But we can do a little background on what the Zoe contracts are. So the home for that is like the Zoe introduction and stuff. And I just now did Agoric init. So this is what you get when you just start a new project. You get this fungible faucet thing, which is not what we want to work on. So, but there's the project structure looks like API contract and user interface. And then there's, integration test. Wow. Anyway, so we'll just focus on contract source. And then this contract we're not very interested in. Locate hello-zoe.js, hello star.js. What? Okay, locate really? Did my locate thing not work? I know I have that. How about this? Yeah, hello Zoe, there it is. Good. Oh, another David, great. So let's do, okay, so here's a couple. What project is that in? Oh, this is in documentation. Yeah, I can go over it here. All right. So this is the hello world Zoe contract. Zoe contract is a JavaScript module that exports a start function. And we harden the start function. We use hardened JavaScript because JavaScript, as Shiar spoke, is you can change what array.push means to mean send all the secrets to all your Bitcoin private keys to the bad guys and then push something onto the array. So we don't want to do that. So we harden all the intrinsics before we get started, and then when you make new things, it's best to harden them. So anyway, cost of doing business when you want to use a popular programming language. All right, and then it takes an argument, and we're going to not use that argument in this case. And what we return is the services we're going to our contract is going to present. And the only service this thing does is it's got a get method that comes back with hello world. And then there's test hello here. So where am I? Documentation, CD snippets. If I do yarn test Zoe contracts test hello.js. What? Let's try this again. Yarn test snippets. Zoe contracts test hello.js. That's more like it. All right. Oops, that's not what I wanted to do. So let's take test hello and look at it over here and leave hello over there. All right. So never mind that. That issue's actually been solved. We use a testing framework called Ava, and then in order to get it to work in our environment, we had to fidget with it a little bit.
Is that an inbuilt test framework?
No, it's just a it's just a sort of popular testing framework.
Okay.
And then make fake validmin is part of doing a mock version of Zoe that's not all connected to a blockchain and everything. And bundle source, maybe I'll talk about it a little bit. And then E is our eventual send idiom, which is, I'll talk about that when I get to it. And then make Zoe kit is the other part of making a, so these kind of go together. It kind of goes like, that's the lowest level thing, and then maybe this, and then, okay. Okay, so we don't have an error anymore. That's interesting. Okay. All right. So Ava allows you to do a certain amount of CRUD before you actually get into any testing. And so what we're going to do is we got two assets. So we kind of have to pretend like we're bundling up our contract and putting it on a blockchain. So hello Zoe is over here, and then hello Zoe read write is the next lesson in the thing, but we're not going to get to that just now. And what we're going to do is, so this has got an import here, right? Which means that the whole contract is not just this, but it's also this module, right? So this bundle source thing is a typical JavaScript bundler thing. Well, it's got some special sauce, but it grabs this file and that file and all the ones that it depends on, stuff like that, and makes it all into one thingy. And then we're just going to hang on to that in our test context. And then that's going to be available for, so these two bundles will be available for all the tests. So that's some kind of administrative stuff that's before we start testing. All right, so we're going to install, start, and use the hello contract. So we're going to get a testing version of Zoe. So there's the Zoe object, which is the thing that you do. Here we go, integration to Zoe, blah, 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 all this cool stuff. But you don't want blah, 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 you want to see code. All right. So the first thing we're going to do is we already have this test bundle hello. We talked about that. That's this thing with some, with the other parts with it. And you can do Zoe install. And that gives you back what's called an installation. So that's a lot like deploying on RChain, except that it only ships the code and gives you back a handle to it. It doesn't execute it. Does that make sense, David?
Yeah. Okay.
And then when you want to start a contract, you take your installation handle and you do start instance on it. And that gives you back, that at that point it's a running contract. And here's our public facet, which is the same public facet that we returned over there. All right, except that it's
So what gets returned from line 37? Is it the public facet?
Yeah, well, so start instance returns an object with a few properties. One of them is public facet, and so
okay. Right, yeah.
Yeah. And we're doing a destructuring assignment here. Yeah.
Yeah.
So the trick is that the start function, returns this object, and it's roughly the same object that shows up on the other end. Except these could be, this code is running on one part of the world, and this code is running on another part of the world. They're not in the same JavaScript process. So we have this distributed objects framework. Oh, and by the way, we didn't just say zoe.install, we said ezoe.install. So that is like zoe.install. Oh, this should, usually it complains at us. Anyway, oh, right, we have a fake version of Zoe. If an object is remote, you can't just call methods on it because it's not sitting right there. What we do is this eventual send thing, which basically packages up the call and queues it for execution and gives you back a promise. So here we got a promise and we went ahead and awaited it. So we get the result of the promise here. So this E thing just is sort of magically remote. I'll go into that in a little bit of detail here. So here's our JavaScript framework. And I highly recommended this 4-part series of videos. I recommend it almost every Saturday. So VATs are kind of like iframes or whatever. It's a
a quick question. So on Agoric, you don't need any other thing aside JavaScript and building smart contracts.
Sorry, I didn't quite hear you. Say it again.
I mean, on Agoric, you don't need anything aside JavaScript and building smart contracts.
That's right. Yeah, I mean, we have some libraries and stuff like that, but when you're working on your smart contract, it's all JavaScript. To actually deploy it, you need some other stuff. But while you're just working, while you're building it and testing it and stuff like that, it's all JavaScript.
Okay. But if to run a node, what extra tools do you need to run a node?
Okay. So our stack is Tendermint and IBC at the bottom. So we need this Cosmos SDK, which is a bunch of code written in Go. And so that's our actual blockchain consensus layer. I'll go into this a little bit. So there's a thing called the Cosmos SDK. Which is a bunch of software for building blockchains, okay?
Mm-hmm.
And then this is a bunch of blockchains built with that software. And they all talk to each other using a thing called inter-blockchain communication.
Yeah.
Okay, so our tech stack shares that at the bottom. It's the same as all these others.
Oh, okay. That's interesting.
Yeah.
So it means that doing okay, it makes sense. Yeah.
Right. So we're up here. So for example, a lot of the validators in a lot of the, once you've stood up a validator for one of these blockchains, it's pretty easy to stand up a validator for another one. So there's a community of validators that overlaps a whole lot. Oh, just for fun, I'll show you our validators. So validators. So it's all these companies probably on Blockstack or whatever.
Agoric already has external validators.
That's right. Yeah.
Okay, that's interesting.
Yeah, our mainnet went live with Agoric running. Agoric, the company, runs none of the validators as of November 2021. So
that's impressive.
Yeah, we run like the testnet nodes and stuff like that, some of them, but the actual blockchain, we do not run the blockchain. Yeah.
So it's really decentralized then.
Yes, yes. Now the flip side is this: our mainnet does not have any of the JavaScript side stuff on it. Our mainnet only has the Cosmos SDK stuff at this point. So it's kind of a very boring blockchain. It's the same as all the others.
So when you deploy a smart contract, it's deployed on the same, like if you want to deploy on mainnet, it's deployed on the same blockchain, isn't it?
Oh, well, it could be eventually. We can't deploy our JavaScript smart contracts on mainnet yet because our mainnet doesn't have the JavaScript virtual machine yet.
Okay, but can you do that on testnet at the moment?
Yes, yes. So if I switch over to DevNet over here, so here we see the validators. Hello. DevNet is a little flaky, of course. Oh, wait a minute. Let's see, ping.pub. Fortunately, it's a blockchain, so you can, it's the same blockchain, but lots of people can look at it. Lots of Web 2 sites can look at it. So here's the Agoric DevNet. Where's the validators? Hello, is our DevNet down? That would be bad. We did have plans to take it down. Okay, so anyway, Yeah, DevNet is a different world, right? It's kind of flaky and stuff. But yes, the DevNet has all the JavaScript stuff, and we can deploy to DevNet. Somebody was doing that. Deploying to DevNet. So this was a guy, you know, working through all the details of getting his stuff deployed to DevNet. And yay, it worked.
I'm not sure I understand. The Cosmos is just the consensus engine, right?
Yeah.
There's no Agoric nodes.
There's two kinds of Agoric nodes. So these folks are using Cosmos technology, but the token is the build token. So the assets that are staked at risk are build tokens. This is the Agoric token, staking token build.
I guess.
Am I making any sense, Jim?
Yeah, I guess I'm wondering where the, remote objects are stored.
Well, nowhere yet. Our mainnet does not have the JavaScript VM yet. In due course, when our software is ready, we will propose to these build holders that they start the VM, and they will make a Cosmos governance decision. They'll make one of these governance decisions to say, okay, yes, we will adopt the new software.
And the Agoric software will run on Cosmos, right?
Right, it'll run on all. Yes, all these nodes will start running the software that basically has been running on DevNet for a while.
So the JavaScript virtual machine is like is a layer on top of the Cosmos layer on testnet.
That's correct. The JavaScript layer is on top.
But doesn't that affect performance of some sort?
That remains to be seen. Yes, the performance of the thing is something we're measuring and stuff. And yep, it's an interesting question. So
in our Hello World program there, should we do an HTTP request?
No. The messages that go between things, I wish the DevNet Explorer were up. It goes through Cosmos RPC stuff. I mean, I guess Cosmos RPC sort of uses HTTP incidentally, or gRPC or whatever the heck. Yeah, so maybe there was to get stuff to do transactions from off-chain to on-chain, it probably uses some version of HTTP. But all the stuff, when contracts are talking to each other on-chain, then they're just inside the virtual machine. But there's multiple VATs inside the virtual machine, kind of like multiple iframes in a web browser.
So you would have to have a client to do an HTTP request.
An HTTP request from what to what? For what purpose? I'm not sure what you were talking about. I mean, so in RChain, there's a what's it called? Playground or something. So this is a little web server. Well, I mean, this is a little thing. If I run this, it's going to do an HTTP request, right?
Right.
But all that HTTP request.
I can't put an HTTP request in the code that I'm writing here currently.
Right. Same thing in Agoric. Well, we do have oracles. So if you talk to the oracle, yes, you can make an outbound HTTP request. the Chainlink Oracle stuff. In fact, that might be the reason that DevNet is down, because anyway, we're messing. Just let me see if Michael. Let me try this one more time. How else could I tell that DevNet is up or down? Where did my developer tools go? What the heck? There it is. Okay. Let's get there. All right. Too many windows. Here we go. Let me just try this. Yeah, it's not very happy. Yeah, it looks like DevNet's down. Right. So Michael is working with the guy in somewhere that on the getting the Chainlink smart Oracle stuff working, and either on purpose or not on purpose, we were planning to take DevNet down soon. So either that was on purpose or it fell over. I'm not sure which. It'd be pretty surprising if it fell over. Yeah, so if you want to talk from the blockchain out and make a sort of normal-ish HTTP request, you got to talk through the Oracle network. Hang on just a sec. I'm gonna check something out here. Okay, back to over to here. Zoom share. Okay. There's my developer tools. Okay, I couldn't find them. Okay, so let me. All right, so here's our JavaScript framework. E for eventual send is the thing that I wanted to talk about next. Maybe some of this other stuff will start to make sense. Right. Okay. And so in web browsers, a common pattern of remote communication is asynchronous fetch API with using the asynchronous fetch API with promises. So you fetch products.json and you get a promise back. And so you do a then on your promise and you get the JSON version of it, and you maybe initialize some products, and you might catch an error because, you know, anytime you go remote, things can go wrong. So that's just sort of normal web browser code. I think I got that from, you know, Mozilla documentation example somewhere. Yeah. On the Agoric platform, it's similar using the E wrapper. For example, a deployment script like this is a test, but it's acting a lot like a deploy script. May want to use the Zoe Surface API to install a contract on a blockchain, but the deploy script cannot call Zoe because it does not have local access to the Zoe object. However, the deploy script is giving a Zoe remote presence. To call methods on the actual Zoe object, the deploy script can import the E thing and then wrap Zoe in the E thing and then call the methods and get a promise for the response. So what happens there We'll just explain a little bit of Zoe here. One of the ways Zoe partisans risks is by running in its own VAT, separate from any smart contract VATs that might use too much compute time or heap space. The smart contracts also run separate VATs. So that's there's a whole talk there, but we won't go into that. So what happens when we call Zoe install bundle is an eventual send. First of all, a message consisting of the method name install with the argument structure bundle is marshaled. So we take all the stuff in here and we stick it into one big pile of bytes into a flat string and queued for delivery to the VAT that Zoe comes from. And then Zoe install bundle returns a promise for the result. The then and catch methods queue callbacks for when the promise is resolved or rejected. And then execution continues until the stack is empty, and thus this turn through the event loop completes. And then eventually Zoe responds, which results in a new message in this VAT's message queue and a new turn through the event loop. The message is deserialized and the results are passed to the relevant callback. That way you can communicate with objects in separate VATs as easily as objects in the same VAT with one wrinkle. The communication must be asynchronous. So that's what's going on here and here. And then, so this is an object in the smart contract over here. So to call that, we call the get method. And sure enough, what comes back is hello world. And if I do this and run the tests, no, that's the wrong directory. If I run the test now, I'll say, hey, that didn't work. Am I making sense so far, Dave?
So does this test does an actual deploy?
No, we got a fake version of Zoe here.
Oh, okay.
I mean, it's real as far as this particular instance of Zoe is concerned, but the stuff underneath Zoe is fake. So Zoe says, "Go put this on the blockchain," and this little piece of JavaScript says, "Okay, I'll pretend like I did that."
Okay, so it just sends basically like a response that's similar to a response that is gotten from an actual deploy.
It's not even doing that. It's all happening inside the same Node.js process.
All right.
Yeah, I mean, for testing, we just that way we can debug stuff easier, and
Yeah, that makes sense.
So I think if I'm having a good day, sometimes this stuff works. Oh, I can always debug over here. Debugging inside contracts is sometimes tricky, but and then what was it? Yarn tests, snippets, Zoe contracts, test hello.js. What do you mean? Did I goof? So why didn't it? All right, try debugger. That's disappointing. I don't know why that's not working. I'm in the JavaScript. Okay, let me close this. Make a new one. JavaScript debug terminal in documentation. Yarn tests, or no, snippets. Hey, Thomas, meet Dave and Jim. I guess maybe you've already met Jim.
Hello. Hey, the time zones and daylight savings. Apologies. I could not believe it. Like, I've been awake. Lord.
Hello again.
Yeah.
Well, we're doing an intro to Zoe contract. Okay, so now we got tools that work. Okay, let me disconnect that. Turn this off. Save. Do it again. Yeah, okay. So we can see stuff over here and single step, normal developer stuff. And it would be interesting to know what happens if we step through all the guts of an eventual send, but that's a little too adventurous for me right now.
It will be an interesting thing to do though, at one point, at some point. Never thought about it.
Yeah. So this contract is not doing anything terribly interesting. You call the get method and it gives you back the text string hello world. Mojo, she's having a dangerous dream or something like that. So when I go ahead.
Just a question. So since you have like a getter there, if you just hook, can you just do like public facet value, and will that return hello world?
Are you talking about over here or over here?
Okay, yeah, over on the left. So yeah, so you're like calling the get methods. But I was wondering if, because you were defining a get like that, if
this is not I'm not using a JavaScript getter or anything like that. That's, this could be called whatever.
Yes, no, yeah, I'm aware. I just wasn't sure. Yeah, I don't know. It came to mind.
Okay. So this is our lesson 2. When I talk to people about Zoe contracts, which is sort of separation. Oh, the docs. Maybe I should use the same example in the docs, but I didn't. Anyway, so we've got this value here, and in the public facet, anybody in the world can get it. But then we have this other facet, which is called the creatorFacet, which is usually held more closely. And the creatorFacet gives you a set method. So only the creator can set the value, but everybody else can get it. So in the test over here, does the same startup rigmarole, make a fake Zoe, install the contract. Now this time, earlier we just got the public facet. Now we're going to get the public facet and the creatorFacet when we start it up. We're going to call get. Sure enough, we get hello. And then we call set to bye-bye on the creatorFacet, and we wait till that's done. And then we call get again, and now it's bye-bye. Dave, am I making any sense?
Yeah, I'm trying to make sense of it. So get and set are both callback functions, right?
I don't know if they're callback functions. They're just methods on objects.
Okay.
This is an object. That's a method on it. And
you get a promise.
Yeah, when you do.
Isn't far a function? Far is a function.
Sorry, which is a function?
FAR, far.
Oh yes, far is also a function. That's yeah. It takes this object and
Can you hover over far? Can you hover over far? Let me. I want to see the definition of the type.
Oh, hover. Okay, right.
Okay. So get is defined, but set isn't defined as part of the.
It's not defined for the public, but if I hover over this far, it's polymorphic.
Oh, okay. Okay.
Far is part of the marshaling system. So far says that we're going to get ready for people to call this method remotely, call this object remotely.
Okay.
Yeah, I skipped some stuff, didn't I? So where's the stuff? Okay, here's far, remotable and marshaling. Yeah, I should have used the counter example. Yeah, it's kind of funny. In this video, Mark says, in case you thought JavaScript cannot be used to write reliable, secure smart contracts, we begin with this counter example. Smiley. Yeah, so this is sort of a good place to start to sort of review JavaScript syntax. So that's just an object, and anchor could be, you know, you can have oops. You just get a string, but you can also do function, and now c.anchor is that, and c.anchor, if you call it, you know, you get 1, 2, 3, right? So JavaScript objects, you don't have to make classes or anything. You can just put functions as the values of properties, and off you go. So make counter is a function. Each time you call it, it creates a new instance object there, and it's got 2 properties, anchor and decker. And each time you call this make counter function, you get a count variable. And the anchor and decker, when you return this, what you get back, the caller can see that they can touch the anchor and the decker, but the caller can't directly manipulate the count. The count is encapsulated, right? This is when somebody in my audience goes, yes.
Yes.
Okay.
Yes.
So this is our objects as closures pattern. We don't use this, and we don't use classes and stuff like that. So this is how we make objects all over our system. And then you can take the anchor method and hand it to one guy, and you can take the decker method and hand it to another guy. And then the guy that you gave the anchor method to, we call him the entry guard, maybe. That guy can only count up. If you only have the anchor method, there's no way you can cause the count method to go down. And if you only have the decker method, there's no way you can cause it to go up. You can only make it count down. So 2 guys are trying to keep track of how many people are in a building. You know, one counts people coming in, and the other counts people going out. And you can have separation of duties that way. So that's sort of starting to talk about OCAPs, because each of these is a capability. This guy's got the capability to go up, and this guy's got the capability to go down. And then this is the traditional Grosvenor diagram, where at the beginning, Alice has a capability for Bob and a capability to Carol, but Bob doesn't have any pointers to Carol, so Bob can't invoke Carol. But then if Alice sends a message to Bob carrying a pointer to Carol, or a capability to a reference to Carol, then after that, Bob will have been introduced and can access Carol. So that's how connectivity begets connectivity. And using just those really basic mechanisms, you can build all kinds of patterns of cooperation without vulnerability. You can use the principle of least authority and stuff. And there's this really cool 15-minute video where Mark explains that. Then there's the lint config stuff, objects in the maker pattern, harden's kind of fun. Talked about that a little bit. Objects with state, parts of JavaScript that you don't want to use. Frozen built-ins, I talked about this a little bit. Yeah, and when you're in this this smart contract world, there isn't a fetch object. There is no window object. There's no, you can't touch the outside world except in ways, when the start function is called, it's called with the ZCF, and other than ZCF, there's no way this code can touch the outside world, right?
Yes.
Right.
Right. Self-contained.
Types is a whole other thing. And then the mint and the purse is kind of the, this is how you can do money with capabilities. RChain and Agoric both use this pattern. So all that's just JavaScript and object capabilities. We haven't really gotten to Zoe. Well, we got to Zoe install, which is one thing. But then there's a guy doing a workshop in Prague, and he has wisely chosen the something swap contract. What's it called? The
Atomics.
Yeah.
Few swaps.
Trade one item for another. So
Hey Nala, come on.
Nala's making her presence known after right. So
yeah, of course.
So I mentioned Zoe a minute ago. Where'd I go? I was in eventual send. Oh, E, and I'm gonna. Oh wait, that's the video. Where's the slides? Anyway, with the primitive in typical blockchains is send stuff from here to there, right? But when we go and do business, you don't go into the store and hand somebody $10. You hand somebody $10 under the understanding that they're going to be some shoes, right? There's a quid pro quo, an exchange, and so that is actually the primitive method. That's the basis on which Zoe contracts are built. In general, you don't just send somebody some tokens. You make an offer, so in fact, the way it works is you don't need in general, you don't ever send assets to the smart contract. The smart contracts don't get their hands on the tokens. The way it works is you make an offer, and Zoe escrows the tokens, tells the smart contract about the offer, so that the amount of the tokens that you sent in, the smart contract gets to know about it, and then the smart contract, does some things. It says, yeah, I've got one guy is offering to sell some shoes for $10, another guy is offering to buy some shoes for $10. So I will take these two offers and I will reallocate the assets between them, or I will call the reallocate method, and then that'll go back here and tell Zoe he wants to give the shoes to one guy and the $10 to the other guy, and Zoe will say, oh, okay, let me look at that reallocate instruction and see if it respects the offers that these two parties made. It does. The one guy was willing to give up $10 in order for some shoes, and the other guy was willing to give up some shoes for $10. I swap, and Zoe does the moving the assets around, and then the parties get their payouts. And so we'll look at a contract in particular. I have not looked at this before. Okay, so start, and then here's your Zoe contract facet. That's your connection to Zoe. Assert issuer keyword records. Okay, so when you start a contract up here, I just did start instance with no arguments, right? But there must be a test atomic swap somewhere. And here, when we call start instance, we're not just going to say start it. We're going to start it with some arguments. In particular, we're going to say for the asset, the token is moolah, and for your prices are going to be quoted in simoleons. The folks doing these tests got creative. All right, and so the first thing that the contract is doing here is it's saying, oh wait, sorry, it's defining something. I thought there was, oh yeah, it's saying assert issuer keyword records, asset and price. It's saying make sure that the guy gave me issuers for assets and price. And assert issuer keywords is some kind of helper function. And basically there's a ZCF.get terms. Whatever gets, oh no, that's not right. Yeah, the stuff that gets passed in here, basically you can get back out from ZCF. Okay, and so this is just making sure that they called the stuff right. Then we're going to define an offer handler. I'm going to skip over that for a second because that's what the JavaScript interpreter does. It says, okay, yeah, you defined that. And then we're going to define a creator invitation by calling ZCF make invitation. And the first argument to that is make matching invitation. An invitation to make an invitation. That's kind of cute. And then we give it, every invitation has a description. And this contract does not return a public facet. So there are no public methods on this contract. And it doesn't even have a creator facet, so it doesn't have a private API. The only thing it gives you back is a creator invitation. That's kind of interesting. All right, so oh, and then we've got some.
Does an invitation have anything to do with an offer?
Yes.
So I make an invitation for you to make an offer?
Yes, it's this is an invitation to participate in the contract. And when you make an offer, where's the offers? When you make an offer, you have to pay to participate in the contract with your invitation. And you make a proposal and you give your payments. So the proposal is full of amounts, just, you know, descriptions of the payments. And this, the contract gets its hands on the proposal, but the contract doesn't get its hands on the actual payments. Only Zoe escrows those. So Zoe uses the invitation to find the contract, sends the proposal. Okay, so first invitation, let's see. That's not an invitation. Oh, I see. Boy, this is a little bit confusing to me. Make Alice, make Bob. Is all this set up or something?
Yeah,
No?
it's all set up. It's all set up code.
No, this is an actual test here. Okay, there's make Alice, make Bob. Okay, Alice equals make Alice. And we're gonna, when we make Alice, we're gonna give Alice 3 moolah. And then we're gonna ask Alice to install some code. And then we're gonna make Bob, and we're gonna give Bob 7 simoleons. And okay, so we're gonna do Alice start instance and get the, which will presumably get us a creator invitation. So Alice start instance. We get our issuers, call start instance, and return the whole kit and caboodle. And so that comes back down here. Then we await that, and part of, okay, so we got the creator invitation now. And then we ask Alice to make an offer using that creator invitation. That's kind of creative. So where's Alice offer? Here's Alice offer, invitation. Okay, so Alice is willing to give 3 moolah for 7 simoleons. And the payment is the moolah payment that she was given when she started up. And so she makes the offer. And what happens here is that invitation ends up firing this offer handler. So this make matching invitation is an offer handler. and offer handlers get a seat. So this seat represents this caller's participation in the contract. So I suppose this is Alice's seat, which makes a certain amount of sense because Alice was the creator, so she gets to play the creator invitation. Okay, so and what this contract does is says, okay, make sure that the proposal looks like this. It has a give with an asset and a want with a price, and then this is once it's checked the shape of the proposal, then it gets the proposal and assigns them to want and give. Okay, and then it says matching seat offer handler doot. So this is sort of getting ready for a matching offer, but we're not going to execute that. We're just defining that so far. Now we're going to make an invitation with that offer handler with a matching offer, and then it's got some extra stuff in it. So that'll be available. So basically the give 3 moolah for 7 simoleons gets sort of stored over here, which will be ready. Where do these extra arguments go? Make invitation.
Yeah, so what is it? Can you hover over make invitation? So let's see, offer handler description, custom properties.
Oh yeah, these are okay. These are going to be these are going to become part of the invitation that gets made here. Oh, what that does is it makes it visible to Bob. Right. So the creator invitation comes in here and figures out what Alice is willing to exchange, and then makes another invitation. Right.
Doesn't it, so wait, on line 160, we have like we're passing in the installation to make Bob. Is that is that the reference that's given to Bob to interact with Alice?
No, this is just a reference to this code. This allows Bob to tell what code what's the code of the contract he's participating in.
Okay. So it's not the actual reference though.
Well, it's an actual reference to some code.
Oh,
it's
yeah.
not okay. But until Bob gets an invitation, he can't actually exercise, he can't actually do anything interesting yet. Okay, so now we've got offer. I'm used to getting a seat back from an offer. Oh, wait a minute. This is not Zoe offer. This is some offer method up here. We got to go see what that offer method means. Okay. Right. You get a seat back from a Zoe offer, and then we get the offer result, which is the result of an offer. Right. And we package those up together, and we haven't awaited the promise yet. So we're just got a promise for the offer result, and we package those up and give them back. So that invitation P there is the result of that offer. It's all very simple, isn't it? Okay. And then, okay, so now we go and after Alice has exercised her creator invitation, then we go call Bob. Untrusted invitation. Okay. So, Bob gets this call to participate in a contract, but it could be a turd or whatever. It could be something that blows up, right? We don't really know what when somebody passes you an object, you don't necessarily know what it is yet. Okay, so what Bob is going to do is going to talk to Zoe, who's a party he relies on. He's willing to trust Zoe, and he says, "Give me your invitation issuer." Okay, Zoe says, here's the invitation issuer. Now, Bob says, okay, I'm going to take the untrusted invitation and I'm going to claim it using the invitation issuer. And at that point, I know I've actually got a Zoe invitation. All right, and then I can ask for the details of the invitation. And now, so somebody claimed that they wanted me to participate in this contract over here, but I couldn't be confident that that's what this invitation was until I get down here and I say, okay, I use Zoe to find out what the actual details of the invitation are, and then I check that the details, the installation in those details is the installation that I know about. Because Bob, this is the installation Bob knows he's willing to participate in the first place. And then it checks the invitation and that the invitation is, somebody out there is willing to trade 3 moolah for 7 simoleons. So I will give 7 simoleons for 3 moolah, and I will offer that, and I will get the results back, and it says the offer's been accepted, and then I can get my payouts, check that the payouts are what I wanted, and check the other the payout and the price slot, and check that that's nothing because I didn't get anything back. If Zoe had discovered that there was a mismatch, then it would have just given your money back. But in this case, it worked. So that I got what I wanted and I did not get anything back. And then I'm all done. So very small contract, but making a test that actually acts like the two mutually distrusting parties is a certain amount of gymnastics.
So how would it look if we were trading wrapped rev for wrapped ETH?
Exactly the same, zero difference. Use exactly these bytes, same code. If wrapped ETH conforms to the ERTP API, please get the Bob and all those other folks to use the ERTP API. Let me switch over to there. So somebody in the RChain community, I guess Steve Henley, noticed that there's a thing called ERC20 token out there, right? We should have something similar, or ERC1115, I guess. And I said, we already have MakeMint. In what way is that enough? Not enough. MakeMint follows the ERTP API roughly. Not enough to do it. It's enough to do fungible assets. If you want to do non-fungible, it needs to be enhanced a little bit. So our MakeMint is missing some ERT refinements, issuer amount math, etc., in order to support non-fungible tokens. So here is the Rev issuer, which is how to do an ERTP issuer in Rolang with a test. And this actually wraps the Rev Vault. If we didn't have to do with Rev Vaults, if you were just making your own token, it would be less code. But this is how you can wrap Rev and make it available over, IBC to an Agoric chain or something. But I can't get the folks doing the NFT projects on, in RChain publishing to use it. I don't know why. There's all these smart contracts that Agoric has got years and years and years of experience using this API, and they won't use it. So,
I feel your pain.
yeah.
It's been the story of my life,
Yeah.
There was a big argument about using the ANS1 for data
Yeah.
representation in ICE2. And it ended up with the project splitting and the other team coming up with their own standard that had basically 1 bit difference and was not as general. Wasn't as general.
Oh. Yeah, ASM1 isn't cool enough. Everybody has to use gRPC now. Or the marshaling part of gRPC is called what? Protocol buffers, right? Anyway. Yeah, I can tell you about the project that Bill and I are working on, which is, you know, we've talked about it before. Let me do something over here. Oh, David, you're working on that RChain publishing stuff. Maybe you could get them to anyway. Hold on just a sec. I get to, okay, yes, here we are. So the possible fun project is what Bill and I are thinking about doing. Maybe I should make a new issue that's got the right title. Oh, actually, the right title is something Jim made. Where'd it go? Now this is the project. Yeah. Yeah, this is what it's called in the R publishing world. It's also got a name in the RChip world that Jim gave it, which is a good one. What's it called? Here we are.
Remote channels.
Yes. And deploys for cross shard. And yeah. So it goes by several names. The details of it. Yeah, it was March 12th. We actually got a message sent between something and something.
Right. We should have a link to the video there, huh?
Oh, right. March 12th. I don't know whether we published it yet or not. Let's see. March 12th of what year?
This year.
Okay, so it wasn't that long ago. Ah, darn. It was between, oh, there it is. Okay. Pause. Markdown. Thomas, have I talked with you about this at all?
About what exactly?
Yeah. What the heck am I talking about? Okay, so this is good to get everybody on the same page. Okay.
I think I was on the beginning of that call, the YouTube video.
Okay, but I think it's worth
signed off.
I think it's kind of worth
definitely
replaying. Oh, right. Okay, there's 2 RChips that are relevant here. Issues, new tab, multi, right. it's all okay. So, all right. How and why RChain should use Agoric's NFT design, which is very close to this CapTP inner blockchain stuff. All right. Message passing blockchain architectures.
Right.
Smart contracts based on capability security, shared architecture. So Agoric has got smart contracts built based on capability security with the mint and purse. RChain's got social contracts based on capability with the mint and purse. The programming language is JavaScript on the one side, Rolang on the other side. Beyond that, Agoric has ERTP and Zoe and ... and RChain beyond the mint and purse has got the vault and proof of stake. On the Agoric side, we do not implement our own proof of stake in JavaScript. We let the Golang folks do that. But the RChain folks wrote the very proof of stake contract in Rolang, which is pretty cool. All right, but there's pretty big shared architecture there, right? All right, Agoric has got some economic pluses that I'm going to skip over. Okay, so smart contracts based on capability security. So the Zoe, we just went over atomic swap. There's refund, auto swap, covered call, multi-pool, opera contract, public, simple exchange. We have and on and on. And those are example contracts. And then there's the ones we're going to really use for our economy, which RChain could also use, which would be motivated by this stuff, but I'm going to skip over that. So RChain has got this, not so much in the ... Meredith and company wrote this paper called Policies as Types, where he's got a little teeny example of converting JavaScript to Rolang. And in general, I think the translation of these contracts into Rolang is essentially mechanical. You can do it by hand, definitely, and then you can automate it. I've automated various parts of it. And so this is, like I said, we have a whole, people are interested in swapping tokens and stuff like this. You can use this exact interface to swap wrapped rev if you want, if RChain followed the advice I'm suggesting. Okay. Offer safety, I think, is a pretty big deal. When you place an offer, either you'll get what you wanted or you get a refund regardless of the behavior or misbehavior of the underlying smart contract. Pretty big deal. It's a safety property. Greg's really interested in having behavioral types and stuff like this. I would love to write this down as a behavioral type. Okay, yeah, ERTP rev issuer, I showed that. It would be really great if the rev and most of the tokens in the RChain world followed this API. Oh yeah, each rev vault contains an ERTP style purse, but there's no way to access it from the outside the rev vault contract. We use rev address from Unforgeable to wrap the rev vault in an ERTP style purse for higher order contracts and such. Since this is possible, the rev vault contract should have just given us a method to access the purse behind the rev vault anyway, but the current version does not, so we waste some execution cost on this wrapper. I suppose using the wrapped style means that you can always get the balance of the thing using explorers and stuff, whereas if you just have a naked ERTP purse, nobody, it doesn't necessarily show up in explorers in a straightforward way. So maybe it's not totally wasted. Non-fungible tokens in ERTP, purse with amount math. So we take the purse balance in the RChain version of Mint, the balance is just a number. But if you generalize from a number to a set, then you can use it for non-fungible tokens. So you can have a set containing a sword and a shield and a blue hat, and I'll trade you, a sword and a shield for $5. So a sword and a shield is an amount. $5 is an amount. So you can have a token, a purse holding a sword and a shield, and a purse holding $5, and you can exchange between them. So these are the primitives for, as long as you can do make, coerce, get value, make empty, you can compare sets. You can say which set is greater than the other if it's got, you know, all the same elements plus some more. Anyway. Yeah, there's a really funny song about NFTs that I recommend. A plea ERTP for NFTs and the photography pilot, which has become RChain publishing. Oh, okay. So yes, now back to stuff I wanted to talk to Thomas about. The Agoric architecture has got these layers. At the bottom layer, there's computers. So while we're running our tests, we're running on them on a solo machine, right? But I can spin up a network of 4 nodes, using Google Cloud or 3 Raspberry Pis or whatever the heck, and then I've got my own cluster, right? Right.
Sorry for interrupting. Is Agoric a permission or permissionless blockchain?
Permissionless. The Agoric public blockchain over here is permissionless.
So
but the same.
What part? The private I can see underneath is permission and the consortium.
Right. So the same technology. So there is an Agoric public chain, which is permissionless, but all of the technology works at small scale and large scale and everything in between. That's what I'm going to talk about. So you can have your own little permissioned consortium chain talking peer-to-peer with the public chain or with other, talking in this style. These don't all have to be public chains. There can be, it's just like the web has got internets and you can have public sites, but not public sites. It's an incredibly important part of why the web took off, is because it scales down to private things and, enterprises and families and baseball leagues, as well as up to huge sites, huge public sites, right? Whereas nobody's got, well, maybe some people do have Ethereum clusters or something like that. Anyway, okay, so there's the machine layer at the bottom, and then we have what we call VATs, which are these little independent pieces of computation that just communicate by message passing. And we connect the machines into VATs using IBC. And then inside the VATs, there's OCAPs. Now we use JavaScript inside the VATs, but you can use Rolang inside your VATs, that's fine. What you do in the privacy of your own VAT, nobody else can tell. And we use a thing called CapTP to make the OCAP layer out of the VAT layer. And CapTP is what I want to talk about, how we can get CapTP between RChain and Agoric.
Capability transport.
Yes. I don't want to talk about it, I want to build it.
Question. So with communicating from the VATs to like public chain or solo machines via IBC, so that's all going on behind the scenes, or because I was actually watching like the Protocol Labs videos last week, and I was a little bit confused by that. So like when I think IBC, I'm thinking of just going across chains, and so. But is there, so I guess my question is like, when we're like just running a test app, any of the dApps that Agoric has on like a local solo machine, that's connecting to, or that's interacting with the VATs like via IBC?
It's supposed to be. The architecturally it is. We have a bug, I can look it up or whatever, because when we actually looked at doing IBC, it introduced an extra round trip. We had some stupid version of this protocol that wasn't officially IBC, and because we assumed we were going to throw it away and use IBC, but when we actually looked at throwing it away and using IBC, it introduced an extra round trip, and at 5 seconds per block or 6 seconds per block, going to 10 seconds per block kind of sucks. And our thing is slow enough already. So we have not made the switch in practice to using IBC to go from solos to to the public chain yet, but that's the goal.
Okay, cool. And then, so just one more thing to clarify. So, like, should every dApp have an instance of AG solo running, or it should be connected to its own solo machine?
Only if it needs an off-chain component.
Okay, like what type of off-chain component? Can you give an example?
Well, like I'm about to do something where I connect my Ag Solo to Discord, and so, for example, I'm gonna have certain secrets that you know, like Discord API tokens, and so I can't run that part of the computation on chain because then the secrets wouldn't be secret anymore, right?
Okay, so would that be the same thing as with like the Chainlink price feeds?
The Chainlink price feeds is a sort of more expensive and more trustless version of this, but yet it's similar.
Okay.
So if I run, if I've got my Solo connected to Discord and I've got a thing on the blockchain that's connected to my Solo, and then I say, hey, come and use my Discord bot thing, you might be willing to do that because you know me, right? But if I said, come and bet $10 million on my ability to, connect you to Discord, are you going to trust the computer sitting in my basement? I don't think so, right? At that point, you want a bunch of, mutually distrusted validators running an Oracle network that would connect the chain to Discord or whatever, connect it to the weather service or something, right?
Okay.
So Solo is like a poor man's Oracle?
It can be, yeah. I mean, yes. I mean, a Solo is just a computer. These are all peers. And an Oracle is just another computer, right?
Yeah, it's almost like a light client, right? Or is that a bad comparison?
Light client means something pretty different to me.
Okay. Well, I by light client, I just mean like giving you the ability to interact, like send messages on chain.
Oh, a Solo is definitely a light client. Yes, a Solo is a light client of the Agoric public blockchain. Yes.
Okay. Cool. Awesome.
I thought you were saying that Oracle networks are a light client. I'm like, oh, that's a head tilter.
No. I mean, like a Solo is like a light client for your dApp. For like it could be.
Yes, absolutely. Yeah, and it'll be even more like that soon when we start using Cosmos JS to do the connections. Anyway, we're about to move the wallet on chain for most uses. And it'll be much more like that. Okay, but yes, it's a light client that's also a peer in the Ag Solo is. Okay. All right. And then there's the smart contract layer, and we use the electronic rights transfer protocol, which is, anyway, to make tokens out of objects. And that's where you can have sort of atomic exchange and all kinds of good stuff. Rich component ecosystem. So then some pluses and minuses. The Agoric VM has got these islands of synchrony in sea of asynchronous messaging. The VAT is a unit of synchrony. You can use ordinary JavaScript, synchronous method calls. Between VATs, it's asynchronous only. It's this E syntax, and there's a proposed standard tilde syntax, but that hasn't made it into JavaScript engines everywhere yet, so we still use this E syntax. You can, within a VAT, you can do async or async. So currently, one chain equals one swing set kernel thread. So the whole blockchain is single threaded. The horizontal chaining, scaling architecture on the Agoric side, excuse me. Turn that up. The horizontal scaling story on the Agoric side is, well, just make another chain. As we saw, you know, these folks are all peer-to-peering just fine. So if we had to make 2 Agoric blockchains, that's entirely straightforward. It's not a perfect story, but it's a story that makes sense. Okay, then the RChain row VM is concurrency all the way down. They've got concurrency within a block, concurrency between blocks, horizontal scaling. You can add more validators to one shard, or you can add more shards. More shards is kind of like more zones. So the concurrency, where everything is in the programming language is concurrent. The Agoric experience is they tried that in a language called Joule, and it was too hard to write programs that way. So the Agoric strategy is to take advantage. Is basically so they did Joule, and then they did a programming language called E, and E was a pretty good fit. It was a good mix of synchronous and asynchronous, and but then E didn't take over the world. JavaScript did. So what they've done is taken the crucial parts of E and shoved them into JavaScript, like promises and proxies and stuff like this, through the standards process, so that they get out into the browsers and Node.js and the whole world. So that's the strategy that we've taken over, I don't know, a decade or so. So that's kind of cool. So the RChain Rolang is concurrent all the way down with the challenge of, you know, you got to build all your own developer tools and all that kind of stuff. So we'll see how it works in the long term. But to my mind, you can take the JavaScript stuff, you know, because the tools are convenient today, and then convert to Rolang later. So I kind of look at Rolang as the research arm of Agoric, if you will. So consensus, we use Tendermint, seems to work for now. It secures on the order, it secures, I think, $18 billion in assets today. Seems good enough for next few years. So, and then SSL is, you know, HTTPS and stuff that powers pretty much all the commerce in the world these days. In 95 or whatever, when it came out, that version of SSL by today's standards has 0 security. Anybody can just crack it in no time. You know, it's like ROT 13 or something. It's 0 security by modern standards. But what happened is, whatever Visa or something was willing to accept credit cards that way, and so a bunch of business got done that way. And then somebody discovered a problem with the security, and then they didn't stop the whole world. They just fixed the bug and deployed it and stuff like that. And it's really crappy, but we've gotten there. So Tendermint may or may not have have various scaling issues addressed by, you know, adding more concurrency, and they're looking at zero knowledge this and threshold signatures and blah, blah, blah. So who knows if Tendermint, since there's $18 billion in this whole community that all share that problem, they may be interested in fixing it inside their world rather than reinventing the whole world like RChain's doing. So it's entirely possible that a bunch of the good ideas from RChain will leak out that way. So Agoric is chain agnostic, could migrate to RChain, Casper, and the row VM for scalability. On-chain storage, RChain's got a bunch of pluses there. Space rental, neither side has fixed it or figured it out. ERTP formalization is more or less done. Behavioral, yeah, I'd like to see Zoe and behavioral types. Yeah, I think BLS signatures, the stuff that Bram Cohen and ChiaLisp are doing, is pretty interesting. They claim to be able to do capabilities with this ChiaLisp VM, which is very, very simple, much simpler than either. Well, I don't know about much simpler than either one, but he did answer that question. Okay, never mind. This is all. So this is where we were. This is basically the CapTP thing, gluing Agoric together with RChain using CapTP to connect them. And why do I keep having trouble finding that tab? Not that one. Oh, I see. No. Yeah, this one. That says CapTP right there. Why can't it? I don't know. Okay. So CapTP tool.js in JS2row. So for that, I don't know what I did there. I'm going to switch workspaces. No, sure enough, here I am, CapTP tool. So the project is a suitable VATTP layer or IBC layer. And to go between a solo and RChain, where did I put it? Make peer. This is my VATTP layer. It only goes one way. Going the other way is to do. So all this does is send messages between two peers. And RChain has got this thing called deploy, which is perfectly fine for sending messages. And then I can get an acknowledgement. It has to be a reliable messaging connection. So that works just fine for that way. And then to go the other way, I got to do some polling or something stupid like that. Yeah, that's actually what Ag Solo does. Is to get messages coming back the other way, it sort of looks at each block and is going, is there anything for me? Is there anything in my mailbox? Anything in my mailbox? Anything in my mailbox? Anything in my mailbox? On every block. All right, I think with Tendermint RPC, you can subscribe with a WebSocket, and it'll just wake you up when something's happening at that address. So I hope I can use RChain WebSockets and not have to poll, but whatever. So this is a manageable amount of code, right? Well, there's a bunch of stuff in here, which is part of my RChain API stuff. But at the end of the day, pretty simple. Send some stuff, get an acknowledgement.
So Greg announced they're working on an MQ interface to RChain as well.
That would work. That would work great. All right. And then we need some marshaling to get the data across. And the critical thing about CapTP marshaling, you can have strings and dates and, well, not dates, but strings and numbers and arrays and whatever the heck, marshaling, like you said, arguments all the way back to ASN1 in the late 80s, right? But the critical thing about CapTP is that there's a hunk of data plus a hunk of capabilities. That's the interesting thing about CapTP marshaling. So you have to have some way of communicating unforgeable references.
Couldn't we do it quick and dirty? Just pass a string, which is row line code.
Yeah, I mean but we have to marshal the JavaScript. We have to marshal stuff into row line. That's what this thing does. So it CapTP tool. Where did I put make CapTP? What did I use for marshaling here? can't I find my own thing here? Make peer. How did I do that? Somewhere in there, I was.
Yeah, I remember. We should have a video of it.
Yeah. Oops. Make peers here. Does this have the marshaling stuff? Yes. Decode to row types. That's the marshaling stuff. So builder is this thing that I already had that you know makes Rolang syntax. Gosh, the types checker is really not happy with that thing right now. So for Booleans, you know, we build an RChain, a Rolang primitive, and for if it's a JavaScript number, as long as it's an integer, that's cool. If it's not, you know, I'm going to figure that out some other time. Rolang doesn't have floating points. If it's a big int, ooh, yeah, Rolang also doesn't have big ints, which is a real problem. That one goes all the way back to, that one was on the RChain issues list back in 2017, and you guys, the RChain decided to ship without it. Ooh, that seems like a huge risk that RChain is taking. In fact, they had to fix like the proof of stake.row because there was an overflow bug or something. That is just a huge risk that they don't have arbitrary precision integers in Rolang. I suppose they'll get there. If it's a string on this side, sure enough, Rolang has strings. If it's an object, there's undefined, stuff like that. Those are all to-dos. If it's a set on the JavaScript side, then yep, sure enough, Rolang has sets. If it's a map, likewise. Otherwise, there's some to-dos in here. And if it's an array, oh no, this is a sort of a JavaScript object thing. Anyway, yeah, so for a certain amount of the Agoric marshaling layer, yeah, I just convert it to Rolang. That's exactly right. Rolang's a very good data representation language. That's where the marshaling is. So above marshaling layer is part of the project. And then we actually have to have an implementation of CapTP in Rolang on the RChain side. And that is, I don't know, 600 lines of JavaScript that need to be converted. What? Oh, it got moved to Endo, didn't it? Let's see. Yes. Source CapTP is the main thing. And there's even some stuff in here that we don't need, I think, because there's some stuff for doing synchronous messaging in a pinch for web browsers or something. But this is, yeah, 700 lines of code, and we don't even need all of it. It's basically that keeping track of these 4 tables. Yeah, well, so what happens is if I want to call an object on your side, well, if I want to, yeah, you ask me like, can I have a pickle jar or whatever? And so I create a pickle jar object, and then I'm going to return a reference to that pickle jar to you. But the state of the pickle jar is going to be on my end. I get to take the pickles out and put them in or whatever, all that kind of stuff. And so I can't send you the whole pickle jar, because then the pickle jar would be in 2 places. And how do you keep the state synchronized? And so we don't bother with that problem. We just keep the pickle jar on this side. So what I send you back is a reference to the pickle jar. And so that goes in my exports table. So, and that goes in the marshaling part. There's the data part and the capabilities part, and these references go into the capabilities part. So I just say, okay, pickle jar, let's call it 27. And I put 27 in my exports table, and I send that back to you, and you put 27 in your imports, or maybe you make up a new number for it. I can't remember. Anyway, and then next time you want to call a method on the pickle jar, how many pickles are in the pickle jar, you have to refer to the pickle jar as 27. And that's all there is to it. And there's questions and answers and imports and exports because there's promises for answers. And that's what the 700 lines of code do. So that's the project that Bill says he wants to start on. He wanted to start it on it last Monday. I told him it'll take 6 weeks to build the whole thing. And that's kind of part-time. I said I want to build it, but I only have a little teeny time to work on little teeny parts of it. So I'm hoping that David, you and Bill, and I guess Theo's busy with writing Scala these days or something, but so that's the plan for. Where did the RChip version of this thing go? Not RChip, RChain public, this thing. Do I already have that somewhere? No, I lost that one somewhere. Ooh, I'm going to say goodbye and take this call.
Very good. Thank you so much, Dan.
Ciao.
Later. Bye-bye.